Hello everyone, my name is Tushar Tuwar, Assistant Professor in Civil Engineering Department at Dr. Subhash Technical Campus, Junagadh. Welcome to my YouTube channel. Today I am going to take lecture of Design of Structure which offered in 5th semester, and today topic cover Introduction Part 2, types of steel and grade of steel. So first, reinforced steel, rebar, grade of steel. Generally, RCC mainly three grade of steel: Fe 250, Fe 415, and Fe 500. First, Fe 250 is called mild steel. Characteristic strength Fy is equal to 250 Newton per mm square. Mild steel bar are also known as Fe250 because the yield strength of this steel Fy is equal to 250 Newton per mm square. The stress strain curve of mild steel, a clearly defined yield point. MS bar are very ductile. They are not prefer our high yield strength deform bar because their less strength and weak bond. They are used stirrup in beam, lateral tie in column, and distribution steel in one-way slab. Modulus of elasticity of mild steel is taken as 2 into 10 raised to 5 Newton per mm square. Second, Fe415 Tor steel, TOR, Tor steel, or HYHD bar, high yield strength deform bar. Characteristic strength Fy is equal to 415 Newton per mm square. The HYHD bar have higher percentage of carbon as compared to mild steel. These bar are available in two types. HYHD bar available in two types. Hot two types of HYHD bar: hot roller deform bar, and second cold trice deform bar CTD, और उसे बोलते हैं टोर स्टील TOR. In Indian standard, CTD bar available under trade name of Tor steel. T-strong, T-scone, GIRP, etc. The bar available in three grade for FE 415, FE 500, FE 550. They are heavy corrugation of rib on their surface. Advantage of HYSD bar. HYSD bar have higher yield strength compared to mild steel bar. Second point, because of high yield strength, the mass of steel required is reduced, which lead to overall economy. Third point, the HYSD bar have better bond with concrete. Disadvantage of HYSD bar. First point, it is less ductile than mild steel. Second point, the low percentage of longitudinal steel reduce the capacity of section in shear. With higher stress level, the deflection and crack of the member are large. Third, TMT bar, thermomechanically treated bar. Next, size of bar, nominal diameter 5 mm to 50 mm. मार्केट में अवेलेबल है TMT बार, जो डिफॉर्म बार है HYSD बार 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, 25 mm और 32 mm. और माइल्ड स्टील है वो मार्केट में अवेलेबल है 6 mm, 10 mm, 12 mm, 16 mm, 20 mm, 25 mm एंड 32. और TFT बार है वो 8 mm, 10 mm, 12 mm, 60 mm, 20 mm और 25 mm. नेक्स्ट, प्लेन बार और डिफॉर्म बार. फर्स्ट, माइल्ड स्टील और डिफॉर्म बार HYSD बार. नेक्स्ट, grade of steel, yield strength. Specified yield strength may be treated as characteristic strength Newton per mm square. Mild steel Fe 250 less commonly used because there are lower strength. Stress strain curve, there are low strength 250. Medium tensile steel, cold twist bar HYSD bar, high yield strength deform bar. TMT bar, thermomechanically treated bar. Inner core soft and ductile, outer shell very tensile strength, modulus of elasticity 2 into 10 raised to 5 megapascal. Next, yield stress is read at 0.2%, proof strain at strain 0.002, stress strain curve. Nominal cover and effective cover. Nominal cover is the design depth of concrete cover to all Steel reinforcement including links. It is the dimension used in design and indicate in the drawing. It shall be not less than diameter of bar. As per IS code IS 456-2000, exposure mild, moderate, severe, very severe and extreme. Nominal cover, concrete cover in mm not less than 20 mm, 30 mm, 45, 50, 75. Minimum grade of concrete M20, M25, 30, 35 and 40. Next, exposure condition. The general environment to which concrete will be exposed during its working life is classified into 5 levels of severity: that moderate, severe, very severe, extreme. Table number 3 IS 456, table number 3 clause number 8.2.2.1 and 35.3.2. Moderate, severe, very severe and extreme. Design philosophy. Design philosophy. The object of reinforced concrete design is to achieve a structure that will result in a safe and economical solution. Design problem consists of: first, idealization of structure for analysis. Second, estimation of load. Third, analysis of idealized structure model to determine axial thrust, shear, bending moment, and deflection. Fourth, material specification and detailing of reinforcement. Fifth, detailed structure drawing and schedule of reinforcement bar. Next, design philosophy. There are 4 philosophy for the design of reinforced concrete. Stress as well as steel structure. First, working stress method. Second, ultimate load design. Third, limit state design. And last, performance based design. 4 types of design philosophy. In this subject, use limit state method IS 456-2000. Next, working stress design. Traditional method of design. Second, it is assumed that concrete is elastic. Steel and concrete together behave elastically. The basic of this method is that the permissible stress for concrete and steel are not exceed in any worst combination of the working load. The sections are designed assuming the material obey Hooke's law. Next. Limit state method. In this subject use based on IS 456-2000 used in limit state method. Limit state method. Limit state is the state at which the structure become unfit for use. Two types of limit state of collapse and limit state of serviceability. So first, limit state of collapse, also known as ultimate limit state. Margin of safety shall be available for nominal overloading. This includes the limit state of strength like overturning, sliding, buckling, fatigue, flexure, compression. Second, limit state of serviceability. Satisfactory performance under service load like deflection, cracking, vibration, leakage, loss of durability. If a structure has reached just before the limit state of serviceability and load are removed, the structure regains its original shape. However, a structure achieves collapse load and not recover in original shape and dimension. Next, cover to reinforcement. Why using cover? The main purpose of providing cover to steel reinforcement is, first point, to protect the reinforcement against corrosion. Second point, to provide cover against fire. Third, to develop the surface sufficient bond strength along the surface of the steel bar. Two types of cover. First, nominal cover और क्लियर कवर, उसे हम डिनोट करते हैं ई डैश, स्मॉल ई डैश. नॉमिनल कवर और इफेक्टिव कवर. इफेक्टिव कवर को डिनोट करते हैं स्मॉल ई और नॉमिनल कवर को डिनोट करते हैं ई डैश. तो फर्स्ट नॉमिनल कवर or clear cover. The thickness of concrete from the surface of reinforcement bar to the nearest edge of concrete is called nominal cover. Second, effective cover. The thickness of concrete from the center of bar to the nearest edge of concrete is called effective cover. Okay, the cross section detail of cover in beam. Capital D, cross section of beam, overall depth को हम कैपिटल डी बोलेंगे और इफेक्टिव डेप्थ को हम स्मॉल डी कहेंगे. विड्थ ऑफ बीम स्मॉल बी. रेनफोर्समेंट ऑफ बार उसको हम फाई से डिनोट करते हैं, डायमीटर ऑफ बार, स्टील बार. और एरिया ऑफ स्टील को हम ए एस टी, कैपिटल ए स्मॉल ए एस टी से हम डिनोट करते हैं. यहाँ पे क्लियर कवर जो हमें दे रखा है कि रेनफोर्समेंट स्टील बार के बिल्कुल नीचे और बीम के बॉटम तक का जो डिस्टेंस है हम उसे क्लियर कवर बोलते हैं, उसको हम ई डैश से डिनोट करते हैं। और इफेक्टिव कवर है और रेनफोर्समेंट के सेंटर से बॉटम के बीम के बॉटम तक जो डिस्टेंस है हम उसे इफेक्टिव कवर, E is equal to effective cover, E dash is equal to clear cover, D is equal to effective depth of a beam, capital D is equal to overall depth of beam, small b is equal to width of beam, effective cover is equal to clear cover plus dia of bar divided by 2 half diameter of bar is equal to effective cover, और overall depth is equal to small d plus effective cover, और effective depth is equal to small capital D minus effective cover. Next, as per IS code provision IS 456/2000, nominal cover should not be less than the diameter of bar. Second, for durability requirement, minimum nominal cover shall not be less than value given in IS code 456 page number 47 table number 16 clause number 26.4.2. Exposure: mild, moderate, severe, very severe and extreme. Nominal concrete cover in mm not less than mild exposure 20 mm, moderate 30 mm, severe 45 mm, very severe 50 mm and extreme 75 mm. Okay, next. The given data: B width of beam, D overall depth, इफेक्टिव कवर बीम के बॉटम से स्टील के रेनफोर्समेंट के सेंटर तक बॉटम जो इफेक्टिव कवर बोलते हैं उसे, AST एरिया ऑफ स्टील, FC के कैरेक्टरिस्टिक स्ट्रेंथ ऑफ कंक्रीट एंड FY कैरेक्टरिस्टिक स्ट्रेंथ ऑफ स्टील. Generally, nominal value of cover in mild exposure स्लैब के लिए 20 mm, बीम के लिए 25 mm, कॉलम के लिए 40 mm और फाउंडेशन के लिए 550 mm यूज करते हैं हम. मिनिमम ग्रेड ऑफ कंक्रीट यूज इन कंस्ट्रक्शन फॉर PCC प्लेन सीमेंट कंक्रीट M15. Second, RCC reinforced concrete cement M20, water tank M20, minimum grade of concrete. PCC subjected to sea water M20, RCC subjected to sea water M30, pre-stress pre-tension concrete M40, post-tension zone M30. Minimum grade of concrete used in construction. Limit state method. What are the limit state? First, limit state are the acceptable limit for the safety and serviceability requirement of the structure before failure occurs. Second, the design of structure by this method will ensure that they will not reach limit state and will not become unfit for the use for which they are intended. Next, it is worth mentioning that structure will not just fail or collapse, by violating the limit state failure. Therefore, in piled head, clearly defined limit state of structure usefulness has been exceeded. Next, how many limit state are there? Two types of limit state of collapse and limit state of serviceability. Partial safety factor. Structure should be designed with load obtained by multiplying the characteristic load with suitable factor of safety depending on nature of load or their combination and the limit state being too considerable. Second, the factor of safety for load are termed as partial safety factor for load. The design load calculated. For concrete, partial safety factor 1.5 and for steel partial safety factor 1.15 as per IS 456 2000 page number 68. And value for different load combination are given IS 456 page number 68 table number 18. Next, limit state versus working stress method. Stress analysis was done working stress method, limit state method, strain analysis will be done. Next point, working stress method. Working load is considerable. Limit state method, ultimate load is considerable. Working stress method, total factor of safety considerable for concrete 3 and steel 1.8. Partial safety factor is considerable. Working stress method, next point, it given large section therefore less economic. Limit state method is given small section therefore economical. Serviceability criteria not consider working stress method. Limit state method, serviceability criteria like deflection, cracking, vibration, etc. are taken in considerable. Margin of safety is not considerable. Margin of safety considerable. Next, assumption of limit state method. First assumption, plane section remaining plane before and after bending. Next, second, strain diagram is linear and stress diagram is partially parabolic and rectangular. Next, the maximum strain in concrete in outermost compression fiber is taken 0.00035 in bending regardless of strength of concrete. The relation between stress strain distribution in concrete assumed to be parabolic. Tensile strength of concrete is neglected. Maximum strain in tension reinforcement intersection failure should not be less than. Last point, effective span of beam. First, simply supported beam or slab. Effective span of simply supported member is taken lesser following. First, clear span plus effective depth is called effective span. Second, center to center distance between support.
effective span is equal to clear span plus effective depth. Second, center to center distance between support. Okay, thank you.